My name is Neil DeRosiers. I'm with Mazak Corporation. My background is manufacturing. I'm actually a machinist at heart, Microsoft certified. I've been with Mazak almost 30 years now, coming up on 30-year anniversary. And most recently, my involvement has been with the MT Connect Institute. I'm Mazak's representative at the technical advisory group there. And I'm also the chairperson for the machine tool work group. So my involvement is getting all the other machine tool builders together and discussing what the end users want to be put into this new open standard. A few years back, we've been promoting this now for about 7-8 years. And a few years ago, somebody said, well, are you guys using this MT Connect standard in your factory? And we weren't. So we started what we now call the iSmart Factory. And we really took a different approach to going and implementing utilization in OEE. And what we did was we started from the ground level coming up, where a lot of these software companies and CEOs are looking at what they want to do with all the software, what they want to do once they have the data. The big disconnect has been, how do I get that data? And a lot of the software companies don't want to actually go out on the factory floor and do that connectivity. They just say, give me the data and I'll implement it, and do the calculation, analytics, whatever you want to do. So we started at the ground up, started with connecting our equipment and moving forward in that direction. And we accepted the fact that we don't know where IoT or Industry 4.0 is going to take us. And we realized that the technology is probably going to change along that road as we move forward. And we are accepting the fact that this is disruptive and things are going to change, and we're just going to keep chugging along, and we're going to solve each problem as we move forward. And you'll see in this presentation that number one, we did the connectivity. Number two, we had to address security, and that has been more in the last 2 years. So I meet with a lot of customers, and we invite them to our factory, and we host a boot camp on MT Connect. But there's always this perception from customers, and that is they always sit down and they say, I got to start thinking outside the box. We got to think outside the box. This is IoT. Everybody says we got to think outside the box. And what we're trying to get people to do is, just get a whole new box, okay? Quit thinking the old way and start thinking the new way. And the analogy that I'm giving you is this, is that people want to start getting connected, and they say, okay, well, let's plug it in, get the machine on the network, and okay, now I'm connected. That's the way we've always done it. The problem is how you do that. Rather than just get connected and get data out and you solve one use case, okay, I'm getting data and I'm doing utilization or a simple dashboard. They're not thinking big, and that's the thing that we wanted to change. And we said, let's define all of the use cases that we want to solve. I want to do DNC. I want to do it securely. I want to protect my intellectual property. I want to do utilization. I want to do OEE. I want to do all of these different things. I want to do big data. Maybe I want to do high-frequency sensors. Maybe I want to do analytics and streaming analytics on this high-frequency data. What kind of problems does that lend? Well, you get into bandwidth, the amount of network that you're going to take up. You're going to get into security. And we said we have to come up with one solution to solve all of these things, and we can move forward from there. And that's what I'm going to talk to you about. So along this roadmap, as we started implementing our factory, we realized that there's two constants now. One of them is, what protocol am I going to use? And the other one is connecting and doing it securely. So the first one was MT Connect. That was an easy one because we've been involved in MT Connect since 2007 when it was first starting out. MT Connect is very different because it is open. Nobody owns it. It's an open protocol, and it's run by the MT Connect Institute, which is a nonprofit. So our involvement there is pushing it, promoting it. I'm kind of an evangelist for it. Anybody who's involved in the technical advisory group is. But it's very different in the sense that it is a data model. When we talk about protocols, you usually hear about transports, okay? There's different things out there, like OPC is a big one that everybody uses and likes to talk about. MT Connect is not a competitor of OPC. OPC is a protocol with user-defined data on top of it. MT Connect is a data model, which is predefined data, right? And we can use any transport we want. We use HTTP by default, but you could actually use MT Connect on top of OPC, which a lot of people don't realize that connectivity or that relationship there. So we chose MT Connect. The connectivity part was we've kind of started down the wrong avenue, which is what a lot of customers are doing, is they just plug the machines into a network and they say, okay, I'm connected, I make the machine MT Connect compliant, I'm getting data, everything's happy. But they forgot that security issue. And what you'll hear, and as I move on, is that IT departments will give the network, the factory, their own network. And by today's standards, that's good. But IoT and Industry 4.0 standards, it doesn't meet quite the security requirement that you need. So MT Connect being this data dictionary, you have a dictionary, a Webster's dictionary for English, French, Spanish, Japanese. Now there's this manufacturing dictionary, and we have things such as controller mode, execution state, rotary velocity, any type of sensor or unit of measurement that you want, linear axis, rotary axis, loads, temperatures, things like that. We can transmit all that data in a common format that once every single device is doing that, the data normalization, when you start collecting data and you want to do analytics on it, usually a data scientist, they'll tell you, 70% of our job is normalizing the data from device to device and making sure that, number one, they're all using the same timestamps or the same clock, and number two, making sure that all the terms mean the same thing. MT Connect does that for you natively. In its native format, that's what it does, is gives you this UTC stamped data tags, so Zulu time or Greenwich Mean Time, and all of these terminology is the same across all the devices. Once I have that, I can walk into any factory with a client, a piece of software that consumes MT Connect data, and I can monitor any machine tool or any device in the factory that's MT Connect compliant. So I can use one dashboard and I can pull up everything and everything works straight out of the box. That's very powerful. So the way it works is MT Connect, an OEM will create what they call an adapter. This is not part of the specification, it's an implementation detail. So we write an MT Connect adapter, it collects proprietary information out of the machine and it transmits it to an agent. This is part of the specification. This agent is like a state engine. It has a buffer in there, it holds data, and anytime anybody asks for the information, it can respond and give the data back. It's nothing more than a website. So if you think of all the equipment on your factory floor, essentially you have an agent or a website that represents every single machine tool or device on your factory floor. This is kind of powerful. So now I can sit in my desktop and I can open up a browser and I can go to that web service for that machine and I get data back. I get raw information back, and you'll see it in a second. So if you look on the right, if I were to go to a machine tool, I would see data just like that. And it would tell me, okay, there's an x-axis, a y-axis, a z-axis, and so on. If you're an IT person or a programmer, that's XML, Extensible Markup Language, which is very common. You probably all use it every day and you don't realize it. If you use Microsoft Word, for example, remember how the extension on Word went from DOC to DOCX? What do you think the X stands for? Okay? So you're getting XML and you're using it every day and you don't even realize it. If you go to Google, just as an example, and you're looking at this screen here, there's probably a whole bunch of raw data in the background in XML format that's actually populating that graph or trend graphic, okay? So we're providing raw data from this device in MT Connect. What you do with that data is up to you. So in other words, if you make a device MT Connect compliant, you don't immediately see fancy graphics. What you're going to see is that raw data. Now you go to some of these third-party software companies and say, do you consume MT Connect data? Do you do utilization? Do you do overall equipment effectiveness? I want to get metrics on my factory floor and I want to use a common protocol to do it. Does your product consume MT Connect? And today, a lot of these software companies are now on board with MT Connect and supporting it. So adapters for MT Connect can be hardware or software, and it confuses a lot of people. So if you're going to connect equipment, keep this in mind. You got new equipment and you got legacy equipment. I have 64 pieces of equipment, different types of devices in Mazak at our factory. They're all MT Connect compliant. From the dashboard side, they don't look any different. But how are they implemented? I've got brand new machines, and they're all Windows based, and I write a Windows piece of software, I drop it on the controller, and it becomes an MT Connect adapter, pushes data to an agent. But I have this 35-year-old manual cylindrical grinder in our grind room. I put an I/O unit on there, I grab some electrical signals out, and this I/O unit that we worked with Moxa outputs MT Connect shutter data, which is adapter information. It acts like an MT Connect adapter. Now I can program it any way I want, get signals out, apply some logic to it, and now that 35-year-old grinder looks like a brand new machine tool. So it's pretty cool. MT Connect is read-only. So a lot of people say, hey, if it's not read-write, how do I make this work? Being read-only is very powerful, and the OEMs like it because somebody can't hack or force data using MT Connect into a device. There is the idea of an interface between devices with a read-read interface. So Mazak and LNS were the first to do it. We did a prototype for the MT Connect Institute between a bar feeder and a machine tool where they were reading each other. So I'm reading the agent from the machine and the machine's reading the agent from the bar feeder, and they're handshaking, and it was extremely fast. It was faster than our I/O, and it worked. It was flawless. It worked fantastic. Then they went on and made an interface between a robot and a machine tool. So now we have a one-to-one relationship. They're now working at the Institute on a pilot project that's a many-to-many. So you have autonomous robots and you have machines there saying, I need someone to load material. And robots are going, I can do it, and they'll go over and they'll hook up and do a read-read interface. So that becomes real powerful. From a security standpoint, we love MT Connect. I know somebody can't force information into my machine, but moving forward with cutting tools and different other types of assets that move around the factory and fixtures. If the machine tool wants to go and read, let's say I'm a machine and I'm doing operation 20 on a part, I can go back and read the process data from the other machine that did op 10, and I can make my process more intelligent by maybe making some offsets or something and assure that I'm going to get a good part. So read-read is very powerful. The reason why I like MT Connect so much, and I promote it, in our factory, I don't let anything, any device or anything that goes in the factory, I don't put it in there unless it speaks MT Connect. I want to have a layer of abstraction above my entire factory where I have a common data model. So I don't care down here if you're using OPC, if you're using any of the field bus protocols and you have existing automation systems that are using older protocols, doesn't matter to me. What I want is to augment those current systems and have them output a data model that's common. The power behind that is it means that any system that you have upstairs in your IT room is plug and play. So if you have a dashboard, you got an OEE system, and you no longer, let's say you want to innovate and you say, hey, I want to do this, this, and that, and they say, you know, that's not really where we want to go with our product, and you're like, well, that's where we're going, and you end up parting ways, it's not an issue because everything below that line, it doesn't have to change. If you go out and buy prototype black boxes from some company and it only speaks to their software, you're spending a lot of money on hardware that's not open. So be careful about going down that path. I'm not saying it won't work, but in a few years from now, if you want to expand, you can't. Another downside to that is if I don't have an agent representing every single device on my factory floor, if I want to go and make this custom dashboard for maintenance, and all it's doing is reading the health conditions of the machine tools, I can only read the ones that have an MT Connect agent representing it. Those ones with those proprietary black boxes, you can't read. Kind of defeats the purpose of having that open standard. So in our factory right now, I'm using MT Connect for monitoring. I'm using it for collecting data on our spindles as we have test stands in our factory that we're doing break-ins and we're running the spindles through their tests. I serialize all that data and I say, okay, this is serial number such and such, and I can graph it and I can go back and I have traceability of my, and product lifecycle management of my spindle. Third thing we do with that same data is capacity planning. Do I have enough test stands to do that spindle if we go from 120 to 200 machines per month? So all of this data coming off of that one agent is providing a lot of different purposes, and it's powerful to have that type of pure approach to data modeling. So when I talk to customers, these are the top 5 things that we're dealing with today. Number one, they say, hey, the only people giving us advice on how to connect to the software companies, but they don't want to do the actual connections. How do we do that part of it? Well, that's where we went forward and did it in our factory. We know how to do it right. Number 2, viruses, right? I've got Windows 95, I have Windows 2000 controllers on the factory floor. They're not going away anytime soon. That iron is good. Those machines will run for another 20 years. What's happening with Industry 4.0 and IoT is that management has decided and agreed that the data from the factory floor is now mission critical, which means I have to collect it. So everybody accept that we have to collect the data. That implies that you have to connect it and you have to make it a first-class citizen on your network. That's a real big problem, right? That's a big security risk, and IT is saying, hang on a second, we have issues with that. This is where we stepped in with Cisco and we collaborated and we said, we got to come up with a solution. General security, ransomware. Why are you hearing lately in articles and magazines that factories are being hacked? Why? Because it's a lot more lucrative to hack a factory than it is to hack somebody at home. They know at home they're only going to get maybe $500 or $1,000 from you. As soon as they realized that it was just as easy to hack a factory and that for 1 hour, one device probably cost the company $270,000 or whatever it is of lost production, they're like, wow, I can ask them for $100,000 and I'm way ahead of the game, right? And that's why it's becoming so attractive to them, is because it's very lucrative. So we have to be real careful. Intellectual property. Right now, customers are sending CAD models and information about processing and blueprints and such to their first-tier suppliers. And as soon as they get it out there, as far as they're concerned, it's out in the wild, and they're like, boy, I hope that they're secure. I hope that your first, second, and third-tier suppliers are secure, and our data is not just being shared and stolen. So they want to lock that down, which means the big companies are now looking to their first-tier supplier and saying, if you're not at least X secure, we're not going to do business with you anymore. Okay? And you'll see a lot of that in DFARS compliance. If you're doing any type of Department of Defense work, there's a new compliance that you have to meet called DFARS, and it's basically like ISO 9000 certification. You have certain regulations and such that you have to follow. DFARS has different aspects to it, but one of them is unclassified technical information on your factory floor. How do I secure that? And if you're not doing it, then you got a problem. Where we're trying to address it is with secure file transfer. We're encrypting files to the machines and keeping people from walking around with USB sticks to our machine tools. So we're going to come back to this slide, a modified slide, a little later, but this, in my perception, in my opinion, there's three different types of companies. One is the company that's connecting and doing just a simple dashboard and doing visualization. The other one is someone that's going a little bit further and they say, I want to collect the data and I want to go to utilization and OEE, which means I have to collect the data, store it in a database. Usually the third-party company that has the software is doing that for you, and they're going to give you some reporting capabilities, trending, and so on. The third is a company that's so large that they have all the management system in place, and they say, we're not going to buy anybody's software, but I want to collect that data, and I want to integrate it, and I want to have feedback from my factory directly into that ERP system. And all they're missing is that data collector for getting data into their system. So today, the standard approach to security is what they call a layered approach. And you don't necessarily have to know all the details, other than you probably have a network and you have a firewall and you have another network around that with a firewall, and it keeps going up. And in some cases, they only allow certain data to get through or certain connections to go through. The thing is it's very convoluted on the factory floor, or that whole factory is on one network. Okay? And that can become a real issue. So this whole topology is getting modified today with IoT. So if you look at it from an IT perspective, the IT department today will say, we're going to give the factory its own network. They call it an isolated network or an ISO network. They put it out there and they say, you do whatever you want. All the machines are out there. All the managers' PCs and dashboards and such are out there. And it's just this big petri dish, right, waiting to be infected. And there's too much risk out there. And the IT department is saying, you're not connecting to the enterprise. Our CEO has said that this data is now mission critical, so we have to find a solution to it, and that's what we've done. So we got together with Cisco. We were introduced to Cisco, and we said, look, here's all the things that we want to do. And they say, well, we know how to do factory networking, but they didn't quite understand all the factory use cases. And we said, this is what we have to accomplish. We have to come up with a solution to do this, 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 and so on. And what we did is we came up with what we call the Mazak Smart Box. And it's a collaboration with Cisco, and what I like to look at it is a launch platform for IoT. It's an open solution. There's nothing in there that's Mazak proprietary. Everything in there is off the shelf. Everything in there you could go out and purchase yourself. The difference is you'd probably pay twice as much to do this. Plus, we paid a lot of money to have this box UL listed. It's NEMA rated, so it's sealed. It can drop directly in your factory and meet all your standards for electrical code and such. It'll run anywhere in the world, so it'll take anywhere from 100 to 230 volts. So I can go to Europe with this box, just change the plug, and everything will be fine. So now I have this ability with this to isolate one machine or I could connect multiple machines, but it kind of defeats the purpose of doing security, right? I want to have one machine if possible. The data flow is usually our limitation. I could hook up 100 machines to this physically, but I probably wouldn't be able to pump all the data through here. So I'm looking at about 10 machines maximum, if you had to, one preferably. And what we did was we put a Linux PC basically inside the network gear. So what we have is a layer 3 managed switch from Cisco, an industrialized switch. What is that? If you're not in IT, if you ever walk by the IT department, you see all the racks in there with all the cables, and you see these long things, okay, that's a switch, and it's all networking, it's managed, which means it has a lot of capability in there. It's not something you buy at Best Buy. They took that, we crunched it down into industrial size, put it in a smart box, and I have all of that power out at the edge. And when I mean by edge, we're talking about the edge of the network, right? We have an edge that goes to the internet, and we have a firewall there. Well, now the other edge, the other end is at the factory door. We just took it now with this device and we're pushing it out to the machine tools or the devices on the factory floor. IT tends to not like that, but what we're doing is we said, hey, we got to get IT's stamp of approval on this. They have to accept this and take control of security. They're the ones that are in charge of security of your factory. They have to accept this and they have to start managing it. The only way they're going to do it is if you give them something that they know and understand and have full control over, and that's a layer 3 managed switch. So we put that out there and we configure the security where it's completely locked down, with the exception of read-only MT Connect data. So now I have up to 10 agents running on the switch in a Linux PC, and if you're an IT guy, it's running in essentially Docker containers. We're running it in Linux containers. And so now I get these apps that are isolated and providing data out of there, which means it's also expandable. I can add more functionality at the edge. The other benefit that this gives you is high-frequency data. We're talking about the internet, we're talking about the Internet of Things, and everybody says, I'm pushing all my pictures to the cloud, I'm doing all of this, and we talk about cloud computing, we're talking about all this processing, unlimited processing and data storage. When you think about the amount of high-frequency data you can generate with 10 sensors on a machine tool, when we're talking vibration, things like vibration, the data starts getting really, really high bandwidth. So imagine if you had 50 or 100 machine tools in your factory and you got 10 sensors on each of them. It'd be like everybody streaming March Madness, right, at the same time. Everybody streaming the basketball game, shuts down your network. The IT department has to stop the game or stop the streaming because business is stopping, right? The network starts bogging down. The same thing happens when you do that. So what we're doing is we're isolating it on this one network for one or multiple machines, and now we're doing what's called streaming analytics. I can put an industrial PC in there, and I can monitor all of that high-frequency data. I can analyze it on the fly. And if something happens, I can send a report out via MT Connect and say, hey, vibration exceeded a certain amount, it exceeded the threshold, I made it offset to the machine, or I interacted with something, I send a report or an email. You can do whatever you want, but it's happening very low frequency on your network. So if you do it correctly, you want to isolate that data, and you want to do all your computational things at the edge of the network, and you don't want to transmit that outside. But in the future, we don't know. I got a big question mark there. I have no idea where IoT is going or Industry 4.0. I don't know what technology is coming out, but I do know those constants, connectivity and a protocol. I have to make sure that that's been the groundwork has been laid. Above that, above this smart box, I don't care what you do with it. Once you have that data out, it's entirely up to you. So today's standards for an OEM like Mazak to say, I'm going to remote in and I'm going to diagnose this automated cell that I gave you. A lot of IT departments actually don't realize that some companies put a cellular chip on that automation cell. It's got maybe 3 robots or 3 machines and a robot, and they put a remote connectivity device there that calls out to the internet, connects to a secure location, people are providing as a service. Mazak logs in, and now we have a tunnel. We have a connectivity to that device and we can diagnose it. A lot of people use that, and that's the golden standard. My opinion is it's either going to change or they're going to fix the issue, is because IT departments look at that as a security breach. That's a backdoor into the company. And now I'm taking this cell and I'm making it a first-class citizen on the network, and we're like, yeah, we're not going to have that. So the preferred method by any IT department is a VPN connection. A lot of you probably do that today. You're at home and you want to get your email, you VPN into the company, you make a secure connection, you check your email. It's like sitting at your desk. Why? Because you're being audited. Everything you do is being monitored. They know when you connect, when you disconnect. They can turn you on, turn you off, whatever. They have complete control over, and they know when you've been there. So a VPN is going to be the preferred way for Mazak to get in. They can also create a secure tunnel. Because the layer 3 managed switch is sitting right at the edge, right by the device, they can say, you can VPN in, and when you do, you only have access directly to that machine tool, or whatever's behind that box. So now that we can get in, do what we want, and they know that we're isolated and we're not getting into things that we shouldn't. The other thing that's powerful now is these containers or these apps that I told you were running at the edge. I can put an MT Connect agent out there, an app that'll run 10 agents. I can put a secure file transfer app out there. So now I can log in securely and I can transfer encrypted files, whether it's a binary file, a CAD model, a G-code program for a machine tool, and I can drop it to the box and then eventually to the machine tool. So we're doing that now, and I can demo it if somebody wants to see it, but we're able to do encrypted file transfer. What's powerful about this is now you've just taken the USBs off the factory floor. Nobody has to walk around with it. But the big companies are looking at this one step further. It's like, okay, I can manage my stuff, but now I want to go to my first tier suppliers and say, we want you to have this capability, and we want you to isolate the device, and the reason why is I'm going to VPN in, you're going to give me a secure tunnel right to that device, and I'm going to drop the program or the model on the machine. You're going to make the part for me, and then I'm going to take it off. So now they just restricted the footprint of how people can get their intellectual property. They want to have control over it as much as they can. And we're enabling that by doing secure file transfer not only throughout the factory, but to their first and second tier suppliers. A big problem that people are totally ignoring is scalability. Black boxes, you go install these, what firmware is on there? How out of date is it? How many did I install and where did I install them? So now, with the layer 3 managed switch, I open up Cisco's Fog Director and I open it up and I can manage 100 and some odd thousand units. I can see them all come up on there. It'll flag me and tell me which firmwares need to be updated on the boxes, and I can schedule a deployment of an update to the software on the switch. In addition to that, did I have the apps? The guy with the apps, he can also deploy apps. So if I have the secure file transfer app, or I put a new smart box in, I say, hey, I want to add this new app and I want to add some custom capability that maybe your IT department develops, they can deploy that and look at that from a scalability standpoint too. He can manage thousands of these units simultaneously and see which apps are out of date and schedule updates as well. So now we take that analogy that we had before, the 3 different types of customers, and all we did was chose a protocol as a standard and chose a standard security way of doing this. And you've just enabled all of this. You didn't change anything upstairs, but now you have a secure connection to the devices. You have a common protocol that everything can read, and you enable all of that, including analytics at the edge, computational. You might want to put an app out there that actually is a dashboard that provides you some read data on the fly as just a read-only dashboard. All of that can happen with using this smart box. So it is open. It is something that we look as a byproduct of what we did in our iSmart factory, and we're sharing it with our end users because we realize it's something that needed to be solved, and nobody really wanted to address that issue. Anybody who was connecting machines wanted to do it with, they'd create a device and they say, hey, there's an opportunity for us to make money, and they create a black box and you're buying it, you're using it, but it's not solving all the use cases. You're solving 1, 2, 3 use cases at best. What we want to do is enable you to expand, be somewhat future-proof, so you can expand on this, change it, update it, whatever you want. It's a platform. If you do it right, you're going to get to enable all the things that we know about today, and hopefully all the things in the future that haven't been identified, the new technology. I have people calling me all the time with prototype stuff, and they said, hey, are you willing to try this in your factory? Do you think anybody would be interested in this? And it's a cool IoT solution, like coolant, pH, all the different things on a machine tool you might want to monitor. 3-phase electrical plugs, the quick disconnects that you always see on machine tools, they're coming out with one now. We had it at IMTS. We actually had the prototype of it, and it was MT Connect compliant. And I was reading all 3 legs of the 3-phase, including a temperature sensor on the plug. That's really cool technology, and that's stuff that's coming out and going to be available to you guys. And all you can do is plug it in and expand on it using MT Connect and just expand on it. If you decide to go a proprietary route, you will enable some capabilities. It may be all you ever want to do, and if you're happy, I'm happy. The downside is I hear customers at every boot camp that I do, every quarter, there's always at least one customer in there said, I wish I would have spent the money up front on security and doing it something like this with an open read-only protocol, and I wouldn't have been in the situation I was in, because it cost us more money to fix the damage that was done. So don't be afraid of doing IoT. Don't be afraid of getting connected. Just do it correctly. Get your IT people involved. If you want to have a meeting with us, bring them to Kentucky. We get Cisco involved in the meetings a lot of times, and they can ask direct questions to Cisco engineers, and we'll get you guys going in the right direction. We do have a boot camp, as I said. The next one's coming up October 17th and 18th in Florence, Kentucky, and it goes everywhere from I don't know anything about MT Connect through use cases, security, installing an agent on your laptop, and you're testing against and reading data against the machines in our factory directly. So it's very interactive and very hands-on. This time I'll open up to any questions. Yes? It could be any device. So MT Connect, you know, that's a common misunderstanding is everybody thinks MT Connect is just for machine tools. It's not. The reason why we started with machine tools is that's the biggest value on our factory floor. Everybody wants to know what the machines are doing. But from there we've gotten into sensors, so things like our paint booth. We have a powder coat paint system in Florence where it's all Allen Bradley PLCs. We wrote an adapter for that, and we're collecting all of the sensor data on the whole system, including the chain speed that brings all the parts through the system. We're monitoring the feed rate and all of that. It looks like a machine tool, but it could be anything. Yeah. Any other questions? Great. Thank you for coming.